Roger, LF. Understand you are on the bottom. Congratulations, Victor. Congratulations.
Well done. Beginning exploration of the bottom.
Everyone knows about the Mariana Trench. It has documentaries, record-breaking dives, James Cameron, and decades of media coverage. What nobody talks about is the second deepest place on Earth, sitting less than 100 kilometers from a Caribbean island with 3 million people living on it. Cameras finally went down into the Puerto Rico Trench. What came back from over 8,000 meters below the surface was not what the scientists expected to find. The trench nobody talks about. When people think about the deepest place on Earth, they almost always think of the Mariana Trench. Located in the Pacific Ocean, it reaches nearly 11,000 meters below the surface and holds the record for the deepest known point on the planet. It has become the standard example for showing just how deep the ocean really is. Whether in documentaries, classrooms, or science books, the Mariana Trench is almost always the first place mentioned when discussing the mysteries of the deep sea. The Puerto Rico Trench, however, rarely gets the same attention. Most people have never heard its name, even though it is one of the most remarkable places on Earth. It is rarely featured in documentaries, and few major expeditions have explored it compared to the Mariana Trench. As a result, it remains largely unknown outside the scientific community, despite being one of the most important deep-sea environments on the planet. What makes this especially surprising is that the Puerto Rico Trench is the deepest point in the entire Atlantic Ocean. Its lowest location, known as the Milwaukee Deep, lies about 8,376 meters below the surface, or more than 27,000 feet. That depth is difficult to imagine, so comparisons help. Mount Everest, the tallest mountain on Earth, stands 8,849 meters above sea level. The Milwaukee Deep is only a few hundred meters shorter than Everest is tall. If nearly any mountain in the continental United States were placed inside the trench, it would disappear beneath the water with room to spare. Even more surprising is its location. This massive underwater canyon lies less than 100 kilometers north of Puerto Rico. It exists close to busy shipping routes and populated islands, yet almost nothing about it is visible from the surface. Just a short distance offshore, the seafloor drops into one of the deepest and least explored environments anywhere in the world. The decision to send cameras into the Puerto Rico Trench was not made simply to capture dramatic footage. Scientists had been waiting for technology capable of surviving the crushing pressure nearly 8 kilometers below the surface. Modern deep-sea equipment finally made that possible. The mission aimed to study the trench's geology, biology, and chemistry while answering long-standing questions about one of Earth's least understood places. The images and data returned from the expedition provided valuable discoveries, but they also revealed just how much remains unknown, proving that even today, one of the deepest places on our planet still holds countless secrets waiting to be uncovered. The descent and what pressure actually means. The equipment sent into the Puerto Rico Trench had to survive conditions unlike anything people experience on the surface. Nearly 8,000 meters below the ocean, the pressure is more than 830 times greater than the air pressure at sea level. At the surface, humans live under one atmosphere of pressure without even noticing it, because everything around us is balanced. At the bottom of the trench, however, every square centimeter of an object must withstand a force of roughly 8 tons. That enormous pressure is one of the biggest challenges in deep-sea exploration and the main reason so little of this environment has ever been explored. Without protection, a human could never survive those conditions. The lungs, sinuses, and every other air-filled space inside the body would collapse long before reaching the bottom. In fact, the human body would be crushed in a fraction of a second at that depth. The pressure is simply too great for any natural air-filled structure to resist. This is why deep-sea exploration depends entirely on specially designed vehicles and equipment built to handle forces that are almost impossible to imagine. Designing machines for these depths requires a completely different approach from building ordinary submarines. Engineers cannot leave empty spaces inside the equipment because trapped air would be squeezed until the surrounding structure failed. Every chamber, cable, housing, and electronic component must either be solid, filled with pressure-resistant materials, or specially designed to balance the outside pressure. Even the smallest weakness could cause a catastrophic failure once the vehicle begins its descent. Every part of the system must also be tested and certified for full ocean depth. Many remotely operated vehicles, or ROVs, are built to reach depths between 3,000 and 6,000 meters. While that sounds incredibly deep, reaching the floor of the Puerto Rico Trench requires equipment capable of surviving another 2,000 meters or more. That extra distance creates a huge increase in pressure, demanding stronger materials, better engineering, and far more reliable systems than those used for most deep-sea missions. Everything below 6,000 meters is known as the Hadal Zone, named after Hades, the Greek god of the underworld. This mysterious region includes the deepest ocean trenches on Earth and represents one of the least explored places on the planet. Scientists estimate that less than 2 or 3% of the Puerto Rico Trench floor has ever been mapped or photographed in high resolution. Every successful dive expands humanity's knowledge of this hidden world. When the cameras finally reached the bottom, they were recording landscapes that had remained in complete darkness for millions of years and had never before been seen by human eyes, reminding scientists how much of Earth's own planet still remains unexplored. The landscape that should not look like that. The first images from the Puerto Rico Trench immediately challenged one of the biggest misconceptions about deep ocean trenches. Most people imagine a trench as a long, narrow crack in the seafloor, almost like a giant knife sliced through the ocean floor. The footage revealed something far more complex. Instead of a simple groove, the bottom of the trench is a rugged and uneven landscape filled with towering cliffs, steep slopes, rocky terraces, and massive piles of debris created by millions of years of geological activity. The trench floor is anything but flat. Huge escarpments rise from the bottom, while terrace-like formations stretch across the landscape, each one shaped by powerful forces deep within the earth. Some walls descend at extremely steep angles, and in several places they appear almost perfectly vertical. Other sections are so steep that loose rocks and sediment cannot remain in place for long. Gravity slowly pulls this material downward, constantly reshaping the trench over time. One of the most striking discoveries in the footage was clear evidence of enormous underwater landslides. These were not small collapses involving loose mud or sand. Scientists identified debris fields showing that ancient landslides moved entire cubic kilometers of rock and sediment in a single event. Such massive collapses dramatically changed the shape of the trench, leaving behind giant deposits scattered across the seafloor. Even today, the remains of these events are clearly visible, lying far from the original slopes and showing just how powerful these underwater failures were. The cameras also recorded several fluid seeps emerging from cracks in the seabed. These are places where water slowly rises through fractures in the rock, carrying dissolved minerals and gases from deep below the Earth's surface. Their presence shows that the Puerto Rico Trench is not a frozen or inactive environment. Geological processes continue every day beneath the seafloor, even though the ocean surface thousands of meters above appears calm and peaceful. Another important discovery was the network of fractures running through the trench walls. Rather than being made of solid, unbroken rock, the walls are filled with cracks created by enormous tectonic forces. In some locations, huge sections of rock appear to be held in place only by friction. The shape of these slopes suggests that additional collapses are not only possible but expected over geological time as pressure continues to build and gravity slowly weakens the rock. These discoveries are far more than fascinating geological observations. They help scientists better understand one of the most active regions of the Atlantic Ocean. The Puerto Rico Trench lies close to millions of people living across Puerto Rico and the Caribbean. Studying its unstable slopes, fracture systems, and history of massive underwater landslides provides valuable information about future geological hazards, making this research important not only for science, but also for improving hazard monitoring and protecting coastal communities throughout the region. The creatures that should not be there. The biological findings from the camera footage were, if anything, more surprising than the geological ones. The expectation going into the dive was an environment of extreme scarcity. 8,000 meters below the surface in total darkness, under crushing pressure, with no sunlight and limited organic input from above, the assumption was that life would be sparse, slow-moving, and minimal. The footage from the baited camera equipment showed something completely different. The bait trap was lowered to the floor and left. For a period after it settled, the camera showed an apparently empty landscape. Nothing visible moved. The floor looked exactly as barren as the popular conception of an abyssal environment. Then the amphipods arrived. Amphipods are crustaceans, relatives of shrimp and crabs. In shallow water environments, they are typically small, measured in centimeters. In deep-sea trenches, where fewer predators exist and where the biological rules governing size work differently, amphipods can grow significantly larger. A well-documented phenomenon called deep-sea gigantism produces oversized versions of organisms that are small in shallower water. The amphipods in the Puerto Rico Trench footage arrived in numbers that were difficult to process. From the apparent emptiness of the trench floor within what appeared to be a short period after the bait settled, hundreds of pale crustaceans materialized from the darkness. They covered the bait camera completely. The footage shows a surface of moving, pale bodies working over the bait in a frenzied, coordinated consumption that is genuinely difficult to look at for the first time. The trench floor that had appeared completely empty was, it turned out, full of organisms waiting for an opportunity. The snailfish appeared alongside the amphipods. Snailfish are the deepest living vertebrates confirmed on Earth, found in hadal trenches around the world. In the Puerto Rico Trench, they are present at depths that would be instantly lethal to any other fish species. Their survival at those depths depends on specific biochemical adaptations that counteract the effects of extreme pressure on their cellular chemistry. They carry a compound called trimethylamine oxide that stabilizes their proteins under conditions that would cause the proteins of shallower water fish to malfunction. In appearance, snailfish are deeply strange. They are translucent with skin that has a gelatinous quality and that reveals the outlines of internal structures visible through the flesh. They move with a fluid, undulating motion that looks less like swimming and more like drifting. Their faces, when visible in close footage, have an otherworldly quality that comes from the combination of large eyes, no scales, and the general impression that they are made of a different material than most familiar fish. The xenophyophores were perhaps the most conceptually challenging discovery for non-specialists encountering them for the first time. They are single-celled organisms, meaning each individual xenophyophore is technically one cell. But they can grow to 20 centimeters across, which makes them some of the largest single-celled organisms known on Earth. They live complex lives on the trench floor, building structures from sediment and living inside them. Finding them in the Puerto Rico Trench footage confirmed that the most biologically alien environments on Earth can still support organisms that defy easy categorization. Sea cucumbers, formerly called holothurians, appeared in the footage as well, moving across the trench floor in their characteristically slow manner. Their presence, along with the amphipods, the snailfish, and the xenophyophores, confirmed that the Puerto Rico Trench at 8,000 meters is not an ecological dead zone. It is a functioning ecosystem, organized around different energy sources and different biological rules than the sunlit ocean above, but a functioning ecosystem nonetheless. The threat nobody wanted to find. The cameras exploring the Puerto Rico Trench captured far more than swarms of amphipods and strange, transparent fish. As scientists carefully reviewed the footage, they realized it also revealed something with direct importance for the millions of people living nearby. The expedition was designed to study one of the deepest parts of the Atlantic Ocean, but it also provided valuable evidence about the geological forces still shaping the region today. The Puerto Rico Trench exists because two massive tectonic plates are constantly moving against each other. The North American plate is slowly sliding beneath the Caribbean plate in a process known as subduction. This movement happens at only about 2 centimeters each year, roughly the speed that fingernails grow. Although that seems insignificant, the motion has continued for millions of years. Instead of releasing energy smoothly, the plates often become locked together. As pressure builds over time, enormous amounts of energy are stored beneath the sea floor until they are suddenly released during an earthquake. This connection is far more than a scientific theory. It has already affected Puerto Rico in the past. In 1918, a magnitude 7.1 earthquake struck off the island's northwest coast. The powerful quake triggered a tsunami that reached the western shoreline, destroying buildings, flooding coastal communities, and killing more than 100 people. At that time, most structures were not designed to withstand either strong earthquakes or powerful tsunami waves. Today, building standards have improved, but the island's population has grown significantly, meaning far more people could be exposed if a similar event occurred again. The new footage also confirmed what many geological models had suggested for years. Large sections of the trench walls are fractured, steep, and under constant stress. Massive debris fields scattered across the trench floor show where huge underwater landslides happened in the past. The fresh fracture systems visible in the rock suggest that some sections remain unstable, providing clues about where future collapses could eventually occur. If a large enough section of the trench wall suddenly collapsed, it would push aside an enormous amount of seawater. That displaced water would generate tsunami waves capable of traveling across the northeastern Caribbean. Depending on the size and direction of the collapse, coastlines in Puerto Rico, the Dominican Republic, Haiti, and the U.S. Virgin Islands could all be affected. In an especially large event, waves could even continue farther across parts of the Atlantic Ocean. Scientists are careful not to describe this as an immediate or inevitable disaster. Fractured underwater slopes can remain stable for thousands of years before changing. However, the expedition confirmed that the geological conditions required for a major submarine landslide do exist within the Puerto Rico Trench. The cameras were sent to explore one of Earth's least known environments, but in doing so, they also provided important evidence that can improve hazard research, strengthen future tsunami planning, and help protect the millions of people who live along nearby coastlines. The chemistry nobody expected. Beyond the biology and geology, the instruments that traveled alongside the cameras into the Puerto Rico Trench collected detailed water chemistry data. These measurements revealed another side of the deep ocean, showing that the trench is shaped not only by its strange creatures and underwater landscape, but also by the chemistry of the water itself. Every sample helped scientists understand how this isolated environment has remained stable for centuries while supporting life under extreme conditions. The water at the bottom of the Puerto Rico Trench is incredibly old. Unlike the surface ocean, where waves, winds, and currents constantly mix the water, the deepest parts of the trench remain largely isolated. Water that sinks into the deep Atlantic Ocean can stay there for hundreds of years before rising back to the surface again. In the deepest sections of the trench, that journey can take even longer. Because this water has been separated from the surface for such long periods, its chemical makeup preserves a record of the conditions it has experienced over many generations. This ancient water has very little contact with the atmosphere above. At the surface, the ocean constantly exchanges gases with the air, while sunlight supports algae and other tiny organisms that produce oxygen through photosynthesis. None of that happens nearly 8,000 meters below the surface. No sunlight reaches those depths, and fresh oxygen is added only very slowly. As a result, the chemistry of the trench reflects a quiet environment where change happens at an incredibly slow pace, and biological activity is much lower than in the upper ocean. Scientists found that oxygen levels in the deepest water are lower than in shallower areas, though oxygen is still present. That means life has adapted to survive with far less oxygen than most surface animals require. Fish, crustaceans, sea cucumbers, worms, and microscopic organisms living in the trench have evolved over millions of years to function under conditions that would be difficult or even impossible for many shallow water species. Their bodies use energy efficiently, allowing them to survive where food and oxygen are both limited. The chemical measurements also matched what the cameras recorded near fluid seeps on the seafloor. Water collected around these areas contained higher concentrations of certain dissolved minerals, confirming that fluids are slowly leaking from beneath Earth's crust into the surrounding ocean. These mineral-rich seeps provide important nutrients and create small habitats where specialized organisms can live, adding another layer of diversity to an environment that once seemed almost lifeless. Temperature is another remarkable feature of the trench. At nearly 8,000 meters below the surface, the water remains just above freezing throughout the year. This is not because the deep ocean becomes colder every winter, but because it stays almost the same temperature all the time. While the surface ocean changes with the seasons, storms, and climate, the Hadal zone remains incredibly stable across human timescales. That constant environment has shaped the animals, water chemistry, and ecosystems of the Puerto Rico Trench over thousands of years, making it one of the most unique, least disturbed, and least understood habitats anywhere on Earth. What 2% actually means. The footage from the drone covered a small area of the Puerto Rico Trench floor. The total area of the trench is enormous, extending hundreds of kilometers along the plate boundary north of the Caribbean islands. The percentage of the trench floor that has been imaged in high resolution across all expeditions and surveys conducted over the entire history of deep-sea exploration in this region is somewhere between 2 and 3%. Everything described in this piece, the amphipod swarms, the snailfish, the xenophyophores, the unstable trench walls, the debris fields from ancient landslides, the fluid seeps, all of it comes from 2 to 3% of the available area. The other 97 to 98% is unchanged from before these dives. It has never been imaged. No camera has ever operated there. No sample has ever been collected from it. Scientists working in this field talk about what the rest might contain with the careful language of people who have learned not to assume, because the 2% that has been seen already defied most of what was assumed going in. The organisms found in this small surveyed area already expanded the known range of certain species and confirmed the presence of biological activity at depths where many scientists had not expected to find it in the concentrations observed. If the distribution of life across the full trench floor is anything like what was observed in the surveyed sections, the Puerto Rico Trench contains a biological community of a size and complexity that has not yet been characterized. The geological story is similarly incomplete. The landslide debris fields visible in the surveyed areas document past events. The unsurveyed areas could contain evidence of larger or more recent events, different fracture patterns, different fluid seep distributions, or geological features that have not yet been observed anywhere on Earth. The trench is old, tectonically active, and largely unexamined. The tsunami risk assessment that comes out of the drone footage is also by definition based on a partial picture. The stability analysis of the trench walls is based on the sections that cameras have actually seen. The sections that have not been seen could be more stable or less stable than what has been documented. Until the full perimeter of the trench walls has been imaged and analyzed, any risk assessment is necessarily incomplete. What the footage actually means. The expedition to the Puerto Rico Trench did not uncover a giant sea monster, a lost civilization, or an unexplained object hidden beneath the ocean floor. Instead, it revealed something far more valuable. The mission showed that one of the deepest places on Earth, located surprisingly close to millions of people, is far more active, far more complex, and far more important than anyone could have understood from the surface alone. The discoveries made there are changing how scientists think about deep oceans, extreme life, and even natural hazards. One of the biggest surprises was the incredible diversity of life, thriving nearly 8,000 meters below the surface. For many years, scientists assumed that the harshest environments on Earth would support only a few simple organisms. The Puerto Rico Trench tells a different story. Despite complete darkness, near freezing temperatures, crushing pressure, and limited food, the trench supports a remarkable ecosystem filled with specialized animals and microorganisms. Every species found there has developed unique adaptations that allow it to survive where most life could never exist. These biological discoveries are important for more than satisfying scientific curiosity. Researchers want to understand how snailfish continue functioning under more than 830 atmospheres of pressure, how giant single-celled xenophyophores grow to sizes impossible for most other cells, and how amphipods gather in large feeding swarms despite the scarcity of food. Each of these organisms has evolved unique biochemical solutions to survive extreme conditions. Those solutions could one day inspire new materials, medical research, biotechnology, and engineering designs capable of operating under high pressure or other extreme environments. The expedition also provided valuable geological information. The detailed images of fractured trench walls, unstable slopes, and ancient landslide debris confirmed that the Puerto Rico Trench remains an active geological system. This knowledge is especially important because millions of people live along nearby coastlines. Scientists already knew the region was capable of producing powerful earthquakes and tsunamis, but the new footage provides direct evidence of the physical conditions beneath the ocean that contribute to those hazards. It is not proof that a disaster is about to happen, but it is valuable information that can improve hazard models, emergency planning, and future engineering projects throughout Puerto Rico and the northeastern Caribbean. The Milwaukee Deep, the deepest point in the Atlantic Ocean, lies about 8,376 meters below the surface. It remains in complete darkness beneath more than 830 times the pressure experienced at sea level. Even today, scientists estimate that nearly 98% of this extraordinary environment has never been seen in detail. Every expedition reveals new landscapes, new species, and new questions that no one expected to ask. The cameras that descended into the Puerto Rico Trench answered important questions, but they also showed how much remains unknown. Future missions will return with better technology, stronger equipment, and new scientific goals. Each journey into the darkness brings humanity closer to understanding one of the last truly unexplored places on our own planet. Scientists have explored only 2 to 3% of the Puerto Rico Trench, yet they found strange life, giant single-celled organisms, and evidence of real tsunami hazards. The remaining 98% is still completely unexplored. If what comes next from that 98% matters to you, subscribe and stay with us for every update.